You've heard the stories, right? About dogs going crazy or cats disappearing right before a big earthquake hits. It's this age-old question, one that's usually just shrugged off as, folklore. But what if there's actually some real science to it? Well, today we're going to dig in and explore a brand new scientific framework that might just solve this ancient mystery. So yeah, this is the classic question. For literally thousands of years, we've had reports of animals acting strangely. Minutes, hours, sometimes even days before the ground starts to shake. Is it some kind of sixth sense? Or is there something else going on entirely? It's fascinated people forever, and now science is finally taking a really serious look. And the reports are, well, they're wild, but also weirdly consistent. You hear about dogs barking their heads off at nothing, huge flocks of birds just taking off in total silence, or farm animals getting so freaked out they refuse to go inside. It's this whole range of behavior, from just pure anxiety to a total breakdown of their normal routines. And these aren't just one-off stories. We're talking about patterns seen all over the globe. All right, but to really get to the bottom of this, we have to do more than just swap stories. The real scientific challenge isn't about prediction anymore. It's about finding a physical cause and effect. We've got to shift our whole perspective from folklore to physics. And this quote right here, this is the absolute game changer. It reframes the whole problem. Scientists are basically saying, okay, we believe the observations exist. Now the real job is to figure out why. Can we build an actual scientific model that connects a brewing earthquake to what an animal is doing? That's the detective story we're on today. So, our first big clue comes from changing how we even think about earthquakes. Instead of seeing them as just a sudden, random snap, we need to see the Earth's crust as this massive, complex system that's slowly building up stress until it gets to a breaking point. The scientific term for that breaking point is a critical transition. And honestly, the best way to think about it is that last straw that breaks the camel's back. The earthquake isn't just the snap itself, it's the grand finale of this long, slow process where the system gets more and more unstable. So this step-by-step process is what's crucial. First, you've got stress building up in the rock, sometimes for years. Then, the system itself, the rock, starts to destabilize. It gets wobbly. And finally, it hits that critical point, and bam, you get the quake. This leads to a really fascinating question. Does that long, wobbly destabilization phase send out any detectable signals before the main event? And that question leads us to our second huge clue, which is, well, it's pretty mind-blowing. It turns out that under extreme stress, the rocks deep inside the Earth can actually change their basic properties. In a way, they kind of come alive. So check this out. Normal rock is stable, electrically neutral, pretty boring, right? But you put it under immense pressure, and it becomes a totally different beast. It becomes electrochemically active. It basically turns into a giant underground battery, generating electric currents, shooting out low-frequency electromagnetic waves, and even burping up gases like radon. And here's the kicker. This underground weirdness doesn't stay underground. It can cause real physical effects right here on the surface. It can ionize the air, which might subtly change the way it smells or feels. It can mess with the chemistry of groundwater. It can create tiny little disturbances in the local electric and magnetic fields. All of a sudden, we've got a whole list of actual physical changes that could be warning signs. But wait, it gets even bigger than that. These signals don't just stop at the surface. Scientists have figured out a model that shows how these disturbances connect the ground under our feet to the very edge of space in this incredible chain reaction. It all starts down here, deep in the lithosphere. This is ground zero, the stressed rock acting like a battery, firing off those first electrical signals. Then, those signals travel up out of the rock and into the air. They can actually change the electrical properties of the atmosphere and the column of air directly above that stressed-out region. And incredibly, that effect keeps going all the way up to the ionosphere, the very top layer of our atmosphere. And get this, satellites have actually seen this happen. They've detected weird anomalies up there right above major fault lines, days before an earthquake. This quote just nails the new perspective. Before a quake, the Earth is in a bunch of separate boxes: ground, air, space. It's one big, interconnected, dynamic system. A disturbance in one layer can literally ripple through all the others. And the biosphere, where all the animals live, it's sitting right in the middle of this changing environment.
So, if the environment is physically changing before a quake, who or what is actually equipped to notice these super subtle signals? Well, this brings us right back around to the animals.
I mean, this table says it all, doesn't it? Our human senses are pretty limited, but a lot of animals are living in a completely different sensory world. Migratory birds can literally see the Earth's magnetic field. Sharks can detect impossibly tiny electric fields. Elephants hear rumbles so low we can't even register them. They are living, breathing biological instruments tuned to their world in ways we can barely even imagine.
And this gives us a new scientific name for what's happening. We can call it seismic abnormal animal behavior, or SAB. And let's be really clear, this is not about a psychic prediction. It's a plausible biological response to real physical signals in the environment, signals that we humans are completely oblivious to.
Now, this is a revolutionary idea, but it's not without some major challenges. Turning all this theory and observation into a reliable predictive science, well, that's the next big mountain for researchers to climb.
And scientists are really open about the difficulties. I mean, you can't exactly schedule an earthquake, so it's tough to have your instruments in the right place at the right time. Plus, a lot of the reports are just stories people tell after it happens. And honestly, sometimes animals are just being weird. It's hard to separate a real signal from random animal behavior.
But there is a clear, high-tech path forward. The plan is to set up automated systems to watch animal behavior 24/7 on a massive scale. And then, this is the crucial part, you integrate that data with everything else. You pull in the data from geophysical sensors, from radon detectors, from the satellites watching the ionosphere. It's all about looking for correlations across the entire Earth system.
And this leaves us with a final, really provocative thought. What if animals aren't just passively living on our planet? What if they are functioning as biological sensors that are actually embedded within the Earth system? Maybe, for certain things, they're the most sensitive instruments we have. This whole line of research isn't just about predicting earthquakes. It's about fundamentally rethinking the deep, dynamic connection between life and the planet itself.